What's up, what's up, what's up, what's up? Welcome back, everybody. Today we are working on our video editor. So, pitch for the editor is I produce 2 hour long VODs approximately daily. There's maybe an argument to be made that shorter videos are a better format for YouTube, right? When I watch other people's other streamers' videos, I see a lot of like 20-minute stuff. And I do notice that I trend to, if there is a 20-minute version of the thing I want to watch or the 2 hour VOD, I'll probably click on the 20-minute one. There's a reason for that. The little monkeys in my brain, they like it a little better. So I want to experiment and see if cutting this type of content down can produce something that's interesting and like worth watching. But my initial attempts were I struggled. Like just popping open like KDN Live, which is maybe, I don't know, maybe there's a better option, but it's just like a video editor on Linux that I wanted to try. So I tried cutting it down and I was like, oh, this is going to take like at least 4 hours to cut down a 2 hour video. That's no good. The point of me doing this at all is supposed to be that I find it fun. I don't like, if I'm going to make videos and put them on YouTube, like I'm trying to just code and see what comes out of it. And so like putting in like way more effort on like the video editing side versus the coding side, it doesn't make sense. It doesn't make sense. And so the question is, well, can we make this easier in some way? And so the idea here is that it would be kind of fun if we could auto-generate like a script for the video and attach that script to the video editor itself. So my thought is that I could like select sections of text of things that I said and said, I want that in and I don't want that in. And maybe like you can like start making like a tree of tags and stuff so that you can like try muting stuff and unmuting stuff, and your playback will automatically hop around and show what's selected. And then like I want to like be able to export that pretty quickly, so hopefully avoid all sorts of like re-encoding stuff, because the vast majority of the video that you're exporting should just be a copy paste. You might have to re-encode some frames that don't align with like iframe boundaries, but whatever. So yeah, I drew a little mock-up here. This is what I'm thinking. This is me in the corner, and here's like my little to-do on the top right, and here's my little code, and there's like a little timeline and a script. And today's topic is audio. So we want to, yeah, I guess audio is important. I don't really need to like, I don't need to justify it in any way. If I'm cutting down my stream, I need to hear it. So the plan for today is, really basic. Play some sound, get some sound to play, and then play that sound. And we'll see what happens. So I guess we should show current state. So current state is this thing. We have a OpenGL window that's opened with glfw. He gives us an OpenGL context. We take the video from FFmpeg, we get some frames, we shove those frames into an OpenGL texture, and then we display them. There was a little bit of pain with like color conversion stuff, but not too bad. Yesterday we looked at aspect ratio adjustment, so this feels so good. This is so much better than it was yesterday. Anyways, okay. Let's work on audio. So what's lib for the GUI? No GUI lib yet. I'm trying to avoid making that decision as late as possible because I don't want to think about it. So we'll get there eventually, but for now it's just OpenGL. I'm talking fast. Yeah, I should slow down. I watch all of the videos that I watch at like 2 to 4x speed, and it's really just like fucking broken my brain. I just sit there like that's what's happening in my head, and I gotta slow it down. Okay, what am I looking at? Okay, so if you look up like audio library C, there are a few examples. I clicked on this one, and this one. This one stands out because it's the first on the list. This one stands out because it's made by Mr. Zig himself. And this one stands out because it's a single header C library. And if I just sort by GitHub stars, I think this guy wins. And because I don't really know anything, and I like the idea of a single header library, I'm going to use this one. I didn't really, there's not really much thought going into this. It's just like, it doesn't really matter, right? Like, in reality, all three of these things are probably just wrapping ALSA. And in reality, if I wanted to try a little bit harder, it's probably not that hard to just like pull out, to like build on top of ALSA. ALSA is already a library. It's just like, but then you have this allows me to like think one layer higher. Like now I don't have to think about like ALSA versus Pulse Audio versus whatever the fuck Windows does versus whatever the fuck Mac OS does. Like this is just going to give me something. There's also SDL sound. Yeah, I did look at that too, but it's like, if we're going to pull in SDL, then we might as well render the video player with SDL, and then it's like, SDL is like a lot more than what I want, where these guys are kind of more scoped. Yeah. So let's yoink this guy, and I guess we'll just shove him somewhere. Maybe in source is where he belongs, and maybe our build script will have to compile him in some way. So we should do like add a C source file who is a source mini audio, and we have to define like the implementation flag here. I wonder, usually I split out like a full .c file for this, but I wonder if you can just get away with like defining stuff here. You could add like a -d flag to this flags thing, but it would be nice if there's like, I don't think that you're supposed to do it that way. I think there's like add C. Okay, whatever. We'll do it the other way. We will make a source mini audio impl C, and we'll look at mini audio.h. Oh my god. Ow, there's so much code in here. And then we'll just do the like, slap this guy over here. Boom, 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 boom. And I think that's it. In our build script, we need to add this guy to our compiled files that we're using, and then in our main file, we should be able to, or in our C imports, we should be able to C include mini audio.h. And I guess also for all of this to work, our build script has to say where to find that header file, which I don't think we're doing right now. Oh, we are. That's already there. Okay. So I think we're chilling. This should compile. And if it doesn't compile, then we'll fix it, but it should compile. Give him a sec. He's thinking. The guys in the wheels, they got to turn the gears, you know. There's a lot going on under there. Okay. So now we have our audio library, and the question now becomes, how do we want to test this? The first thing we want to do is like make something that plays some sound. And it's probably easier to make like a new playground for this. Probably. I don't think that, because like I don't think there's anything we don't have like any infrastructure in our existing app that has anything to do with this. So it's probably easier just to start from scratch. So maybe we import std prot import, and then we also import our like C bindings. And then, I guess we don't even really necessarily need this allocator yet. We don't really know if we're going to need it. If all the allocation is handled by mini audio, then we don't really have to do anything ourselves. You did some refactoring off stream? Just a little bit. I just took out, like, the player state. So, like, just the stuff in the main loop where we were saying, like, can we pause? That just kind of got shoved into its own class. Oh, I guess I also fixed a little bit of the, like, heap allocation stuff that we needed to do to make the callbacks work. But nothing too major, It's all basically the same. Okay, what's in this guy? He's going to tell us what to do somewhere. So this guy has like a low level and high level API. I was kind of skimming the API docs before stream, and I think the low level API is fine. Like one of them is like, hey, I want to like take audio files and play them at given times and like mix them together and stuff. And what the low level one's just like, hey, I have like an audio device. Let me like throw some like audio frames at you, and you'll play them. And I think that this probably matches what we want from FFmpeg a little better. FFmpeg is going to give us audio samples, and we're going to have to like dynamically inject them as we load them. Especially if we start like seeking around, then it's not going to be like a linear thing. You could argue that you could like extract the audio and like upload it to mini audio system once and then just have it play. But then you have to really worry about like desyncs between the audio and the video. So just like shoving frames in as we get them, I think probably makes more sense. And if you look at this like low-level API, it's pretty straightforward, right? They're like, hey, I want a device. Here's the configuration for that device. Please initialize it and then like start playing sound on it. And then all we have to do there is like give it some function that it's going to call. Hope with no user data. What up with these like C libraries and not... Oh, never mind. Whew, scared me. Okay, there is user data here. We must just have to like extract it from the device or something. So we're going to have to like set up some sort of like system to be like, I have audio over here. I would like to hand it over here to your callback, and then when it runs, it'll like ask for it. Not really sure about like the threading model here yet, but we'll figure that out pretty quick. So I guess we just copy paste the sample and start going from there. So this has to be converted to a Zig function. So he's going to take in a device, which is whatever the fuck this thing is, a MA device pointer. And we'll call this... Dude, what up with people and naming variables after their types? We did this at one of the companies I worked at, where everything they would name like bool b do stuff, and some pointer like bool star would be like pb do stuff. But we only did it for pointers and booleans. I don't know why pointers and booleans are special, right? And these guys are doing the same thing, where they have pointer, p ma device, p output, p input, but then frame count. Like, why shouldn't this be like u32 frame count if we're gonna like be shoving our types into names? Is that Hungarian notation? I think so. But like, why do it at all? I don't understand. See, like, this makes more sense to me, right? If you're gonna do it, shove your L for long, like you know, S's name. Like, if you're gonna do it, just go all the way. I don't understand this like half-assed version, you know? Hungarian notation, more like Windows notation. Oh yeah, they do that a lot, huh? But they also yell it at you. I've seen like those like Windows types are always in uppercase. Anyways, not that it matters. It's just one of those things where it's like, I don't understand it. What was output was a void star, which is not. I think it's is it void here? I can't remember if we're supposed to do star void or star any opaque. Like, I think we're supposed to do this. I think that Zig says void pointers aren't allowed. I think. Oops, forgot a colon here. And, oh, this is a pointer to a const. Right? Const void is not a constant pointer, but it's a constant element. Yeah. You can tell that I'm a little bit rusty when I'm not sure where the const goes. This is a C uint, or I guess it's a U32. I guess this is a C MA uint32. I guess we should be true to the input. Okay. And then this is going to use the C calling convention. So we have to say, hey, Zig, don't do whatever you're doing that's better. Just do what C expects. And then eventually we'll have to do something. But for now, let's just start by converting their little example into not Rust. What language are we working in again? Zig. I know what's going on. So we'll start by getting some config. And this is going to come from this guy. And I guess maybe just as we get going, it's nice to stay in like a compiling state. So let's get this guy compiling at least a little bit, and then we'll continue on. Do I use a 4K monitor? Nope. Little 1080p guy. But which is fine because 144 FPS is sick. When I upgraded to a 144 hertz monitor, I was like, holy crap, this like completely changed my life. Like for games, it's like no wonder I couldn't name before. But I really doubt that I can drive anything above 1080p at 144 FPS anyways. So it's like, I don't know. And plus, like, my eyes are so bad. My prescription's like, what, like -11 or some shit. And so like, I don't really know if I even like notice. Everything's so blurry anyways. -11. Yeah, dude, it's bad. Check out like the thickness on these bad boys. I don't know if you can see it because I can't see my monitor when I take them off. What was I doing? I was gonna try to compile this. Are you gonna be using some library to handle video codecs? Yeah, we're using FFmpeg. It is fun though. I don't know, like I've done a little bit of working with the H.264 spec. It's kind of fun. It's kind of fun. I don't think I've ever written a decoder straight from scratch, but there's like, I've had to like look at, I don't remember what I was doing. Something about packetization made me look at it a little more detailed, but like that shit's crazy. And would be a fun project actually. Writing an H.264 decoder, that's a good stream idea actually. I should do that at some point. Because there's a lot in there. Like, because they do this weird like frequency domain compression, if I remember correctly, where they like Fourier transform the stuff and then crop out anything that's high frequency because like who fucking cares? You're not going to see it anyways. And there's like that's why you there's also something about like the compressions. There's something about like when you see like dark rooms on like your low bitrate streams, like the darks are so impossible to see and it gets like really blocky and pixelated. There's like some interesting reason behind that I can't remember right now, but it's a good idea. It's a good idea. I haven't either, but I hear there's H.265 now. Yeah, H.265 I don't think is really, it doesn't really benefit much, if I remember correctly. We used H.265 for security cameras at the company I was working with because it supported like sub-streams or something. So if you were looking only at one area of the stream, you could take an H.265 frame and only send like one tile of it, which was really nice. But I think that like outside of that, I don't remember thinking that it was any better. What was I doing? I was going to build our new application. So I guess all of these flags that we're passing to our video editor executable are going to be used on both. So I guess we do something like function make exe, who is going to take in our build, and he's going to return maybe nothing, to be honest. He might return nothing. And I guess we'll just take in the name and the path. And I guess we also need the... Can you extract these over and over again, these things? Probably. I can't, I imagine that's fine. I imagine, but we'll see. So the name goes now is just name, and the path is path. And then all we have to do is call make exe with video editor and source main zig, and do it again with audio test and source audio test. There we go. Expected 3, arguments found 2. Both of these guys need little b's in front of them. Little b's, not big b's, little ones. Signal processing is like 95% Fourier analysis. That makes sense. I can't declare options twice. Okay, so I need to do this target and option parsing here. And I guess what I'll do instead is, because I'm feeling a little lazy, is we'll stick them in static namespace. Or, I don't know what it's called in this language. I don't know what it's called. Global. So this is a stood build resolved target. And this is a stood build built-in optimization mode. Nice. And then here we can just delete these consts. Boom. We good? Is he chilling? We're close. Undeclared identifier MA device. So let's clean up some of these guys. So this is in the C imports. So we shove a little C dot on it. Dependency loop detected. Pub const MA data device proc. Oh no. That's not good. C import zig 6153 dependency loop detected. So does this mean that we just can't use this library from Zig? It's a very real possibility. Okay, so what is he complaining about? He's saying, what is the dependency loop? I actually don't see it. I guess maybe MA device might have... Oh, I don't know. I don't know. But this might be an indication that Do you have to like define the impl precompile var like in the C file? I did. No. I shouldn't do that in the Zig imports. Yeah, that's annoying. That's annoying. So I wonder if they're mad because MA device has a MA device data proc in it, and this uses an MA device in here. Like, I wonder if I do this, if it likes that better. Just out of curiosity. Just out of curiosity. That did get me into a different error. That's annoying. Zig's C import dependency loop. I build success by modify. This guy is not a native English speaker for sure. This guy just commented just like, oh, he's just posting another error. Expect behavior, build and run. Okay. That's pretty funny. Yeah, interesting. So this, I imagine. Okay, so we can maybe write like a little sample, like a little test case for this. Okay, let's what about erasing the type and just using any pick? I think it's a problem with like the import of the library itself though. So if we let's make a, is there a test, do I have like a test Zig project anywhere? No. I suspect that it's related to, if I were to make a test H, and in here I had like struct my thing, and a member of my thing is like my function callback. And if I declare like my function callback as a pointer to a function that takes in a pointer to my thing, how do you do that in this language? My thing star thing. I think this is what he doesn't like. I think. So we could test this by doing zig help. Translate C. Test.h. Unknown type, my function callback. Oopsies. And then do I have to do this up here or something? And then do struct my thing as a forward declare? Is that how I have to do this? I guess we should test this in C first because I don't remember my syntax well enough. Unknown type name my thing. Oh, so I have to write struct here. Unknown type my function callback. Oh, because I named it the wrong thing. Okay. So if I... Oh, no, he's fine with that. He is fine with that. Okay. So what did we change here? This was the state it was in before. Where this thing, yeah, this guy was in MA device. So I don't understand why translate see the whole mini audio.h. That's not a bad idea. Let's see what that does. Zig translate C mini audio.h. And then we have to say like LP thread. Oh, that works too. Okay. Interesting. And then in here, do we see like a MA? I think it's something with the build script. I don't know what. Yeah. Okay. So let's get a little bit crazier in here. Let's see. So let's try. If you think it's something in the build script, we can check that by doing in our audio test, we can import, instead of doing this import c.zig, we can do c import directly and do a c include of mini audio.h. So now build script is gonna, we can take build script completely out of the question by doing zig build, or sorry, zig run source audio test. And he's gonna say, hey, where the fuck is, oh, he's gonna say, where's mini audio? So I can say include source. Okay, and then he's gonna say no pthread, so we'll type lpthread. And then dependency loop detected is still there. Okay. So the question is why does translate C do anything different than this? And it would be interesting to try to reproduce this now with our little test case here. So if I'm correct, and it's about this, like, this back and forth resolution, translate C didn't define many audio implementations, right? So it only succeeded on a subset, but we're not defining that in our thing either. In our C import, we're not defining it. So it should be the same. Okay, so let's try. If we were to say const C is equal to C import here, and in here we were going to try to C include our little test file, which is test.h. Then we did zig run test zig and include dot. He needs this to be public. No issues there. What if we try to use this thing now? What's in test.h? Const value is equal to my thing is a C my thing equal undefined. And then here we can just maybe like std debug print v so that it doesn't get compiled out. Okay. And then here we're going to import standard library. Okay. Okay, so clearly not as simple as this case, like I thought. It'd be interesting to try to break down the problem to the point where we could fix it. That'd be kind of fun. So let's pivot. We'll pivot. No more audio. I want to know why I can't include this file. We let ourselves rabbit hole here because it's the fun thing to do. The other option would be we could just use a different audio library, which is probably like maybe more sane. But shut the fuck up. You can't make me do anything. This is my stream. Okay. So let's do test.zig and try importing mini audio.h instead. And let's just see if this reproduces the problem. Which doesn't. Why is it different now? Oh, because we actually tried to use something probably? Okay. Wait. Okay, let's go back. Let's go back. Here. And let's go to audio test.zig and start commenting stuff out. Right? If we do this and this, I'm actually gonna get it to compile by type erasing the function pointers. Yeah, so like sorry, brain's melting. In the mini audio.h, you just replace all p devices with pointers to any opaque. Why? Where is it? Okay, so yes, this is fine. And then as soon as I try to use it, probably it starts to break. Yeah. You could also do it in the .h. But how did you do it? Like, you're so in C. You did it in C import.zig. So you modded the compiler. I didn't. Oh, I see. Okay, so when I call C import, he calls translate C. He calls translate C on the header. And so when we called translate C, it was working fine, probably. And then he generates this like translate C file. So if I went to sort, or this like C import file, so if I did a zig translate C mini audio.h LP thread, and then I exported this to mini audio zig just as a test. And then in audio, in our like audio test thing, instead of calling C import here, we said const C is equal to import mini audio zig. And then we tried to run this. I imagine that we'll get the same problem. Yes. Okay. And then you're saying you mod C import.zig to type erase the device pointers. So if I go into mini audio.zig, I should be able to go to MA device in these function pointers here and just change these into any opaque. So I should just search for like this. No, this one doesn't matter. It's maybe only these ones. MA device notification proc. So this guy, again, we just need to const any opaque. Oh, okay. So it is only a few of them. Okay. Interesting. So it would be, I'm also kind of curious about like what the dependency cycle even is here. So it's something related to these guys. So I'm curious. I'm just curious here. Is there any like is there a very simple version of this? It's interesting because it's not. Oh, it is maybe all of them. So if I do this one and put this guy back, do I get an error here? Yeah. Okay. Okay. So MA stop proc references MA device. MA device must have an MA stop proc in him somewhere. Okay, let's just out of curiosity. What if I did this? The dependency loop is still detected. So it would be, I wonder if we can like, can we almost, okay. What if we just get rid of everything except for these two lines, right? Like, let's just get crazy here and see if this is enough to reproduce the issue. Oh. Now the... we need to at least do something here. So const device var device is this thing equals undefined. Unused local variable. So this needs to be const and this goes to device. No, okay, so that's not enough. Interesting. So what? I wonder where this is coming in. I wonder if like can we look at like loop detected. So where does like this come from? So he is going through some form of dependency graph, and I guess he's probably finding... I wonder if we can, like... Do I want to build the compiler right now? Is that what I want to do? Feels like too much work. But then again, just randomly probing is also a lot of work. So, like... What are we doing here? Let's undo all of these changes that we just made. I want to try to, like, start bisecting. So if we can at least find a way to start stripping this problem down to a point where it's simpler, that would just be very useful. Maybe for our own mental model, but maybe also for adjusting that bug report. Okay, so let's go into MA device and just start deleting things out of here and seeing if that causes problems. Because, like, I think that if we're not using this stuff, maybe it doesn't cause a problem. Where's my... Sorry, not this stuff. Where's my struct MA device? Here. Because I don't know if, like, any of the... If the way we're compiling it right now, none of these, like, member variables should be used anywhere, I don't think. I could be wrong, but let's just, like, see what happens if I do this. Well, and then let's also go to this MA stop proc and send it, we'll put this back to an opaque pointer just to see if we can get past these compilation issues. So this is any opaque. Okay, sick. So that compiles. So we can just start, like, nuking code until it starts compiling. Because we know that we were in a state before where we were compiling. So let's delete as much as we fucking can here. Okay, well, let's go back. Where was that stop proc? This is at line 553. We need to remember that. 553. So this is above it. So we should, theoretically, if I just delete everything below here, I think we should still compile. Oh, but he's gonna get mad about unused identifiers, which is a little annoying. A little annoying, but it's fine. So if I just delete all this stuff. Oh, wait. It says that unused identifier MA stop proc? Didn't I leave this in here? Am I high? Okay, delete all this. Oh, it's because when I deleted up here, I probably nuked it by mistake. Yeah, it's here. So let's... Right, like if we do this, delete everything, and go back, I think we were already in this state before, and it didn't cause a problem. Root struct file mini audio MA device config in it. Oh, okay, so we need to keep MA device config in it as well. There's also zig reduce, but I've never used it. Zig reduce. What is it doing? What is it reducing? Zig reduce -h. That's also just doing something. What the fuck? Minimize a bug report. Oh, okay. Did that just, like, fuck up all sorts of stuff in my directory? No, we're chilling. It's compiling itself? Oh, interesting. Interesting. Okay. What's, like, the easiest way to bisect this? Because I know that there is a way, we just have to figure it out. Like, if I guess we just start, like, if I delete all this, obviously that's going to cause problems. Obviously. But how much can we delete? What a pain. What a pain, what a pain, what a pain. proper sort of failure culture gets just the help flag says fuck it and runs it blind. No, it's because when I ran it with help, it did nothing. I tried that. Look, when I type in dash help, it's like starts doing something. And I was like, I don't know what like the doing something is. That's scary. Okay. Okay. So clearly just deleting everything. Bad solution here. But is there an easier, like another way we can bisect? It's interesting that like it's clearly related to something else, right? Because like my MA device. Oh, it must be someone who's using MA device. Hold on. That seems likely. Well, so if we just delete all this stuff, delete this, still dependency loop detected. Like, how much can we delete, you know? MA device config init. So this is what we're using here. Who's using MA device type. Oh, I guess we already saw that it doesn't depend on what function we're calling, just that we're importing this at all. What a pain. What if we just delete... Oh, wait. I know how we can... Let's leave all this in for a second. We're going to leave all that in. And we're going to go to our audio test. And can we change this to do something else? Like, CMA device is equal to undefined. If we do this, does the bug stay? No. Okay, so it depends on us calling this function. Okay, so what if we just keep this and delete everything else? Right? Like, let's just start going crazy. So, device config init requires MA device config. And... oh, well, first, what happens if we just say this returns void? Just temporarily. I know, we shouldn't do that. But I just want to... we don't really care about, like, this being reasonable, you know? Okay. So if he doesn't return the thing, then this stops breaking as well, which is surprising. So it's related probably to the instantiation of MA device config. So if we just say, define right here, this is CMA device config equals undefined. I wonder if that still triggers the dependency. It does, okay. So it's in the device config, we must, like, what if we, like, just zero out this struct? Oopsies. Oh, fuck, what did I just do? Okay, what if I just start, like, deleting stuff from here? Right? Just zero them the fuck out. No dependency loop. Okay, so one of these things is causing the loop. Data callback? Notification callback. Maybe, well, it could be a combination of multiple, actually. So let's see. Bisecting. Ah, okay, wait. I think we found it. Okay, so if we have an MA device config who uses an MA stop proc who takes in an MA device, and then we try to initialize the MA device. Oh, we don't even have to call init. We were just using MA stop proc. Stop proc has a MA device, and MA device has an MA stop proc? So what the fuck does the config have to do with it? If I just do this, does that trigger it? No. Right? So there's something about, like, a reference to a thing that was not very clean words that I'm saying there. But it seems like it's, I think it's like struct. So we have ma device config with ma stop proc. We have ma stop proc references ma device. And we have ma device references ma stop proc. And instantiating this guy causes the problem. Which means that we can probably reproduce this. We can probably like take only this stuff out. Delete everything else, and then copy paste it back in. So this goes here, and then struct ma device. This stuff comes back in. Okay, delete everything else. Take this stuff and shove it back in here. No. Does it depend on the order? Did we fuck up the order by changing this? Okay, so I guess we'll just write down the lines that we pulled this shit from. So this is at 728. Or maybe there's more to it. Maybe there's more. This is 552. And this is at... Oops, we had MA... Wait, where does MA device config go? Okay. Hold on. I think I fucked something up. We're restarting. We're going from scratch. Why is this so interesting? Yeah, I mean, I'm really not really saying or doing anything. So there is... it is a little odd, huh? Okay, MA device config. And this is at line 752. And in here, last time, we... Oh, I guess we should delete first. We delete first. So we go from here, and we say, we only want... I don't even remember which thing was... It was stop callback. Was the thing that caused the bug, if I remember correctly. So here, if we run... Oopsies. Fuck! Oh, no. Undo. Okay. Zig run this. We should see the bug. No, because audio test.zig doesn't exist because we need to do it from here. Okay, dependency loop detected. Still there. Okay. Then we want to pull... Then we also modified MA device. And we basically deleted everything in here except for on stop. Still broken. Okay, so now the theory is that we should be able to reconstruct this with only the relevant players. So this is at 657. This is at 728, so it goes below. And then we had MA stop proc here at 552. And so if we delete everything, we just put this stuff back here. Does it cause the same problems? Yes. But what if we... So what if we put this down here then? Yes. Okay, wait. We've got it. So we were in a state earlier, though, where we copy-pasted in some other order and it was fine. But I don't know how we got there. Maybe I just misunderstood. And then let's just make sure that all of this stuff goes away if I write any opaque here. It does. Interesting. Okay, so this is at least a good test case where we've really like stripped it down. Is there more to say? Is there more to... I guess maybe we could try also doing the same thing. We can try taking out this like mini audio referencing shit. So let's try to make another repro. So what is this? This is a struct uses two different structures use the same function callback. And that function callback references one of those structures. So we should be able to do something like my thing 2 references my function callback. And if we then compile this, then maybe we see the issue. So C import test.h and then try to construct a mything2 and then say discard v. So here if we try to zig run, we have to go to the right folder. Zig run test zig. Zig run -i dot test zig. Dependency loop detected. Let's go, baby. Let's go. Okay, let's rename these things to something that's like a little bit less, like a little bit clearer. So we'll call this function callback. We'll call this A. Type def struct A. Struct B, or so this is A, and this is B. And then here we try to import B. So is it related to translate C or not? I think that translate C is generating some zig that is unusable. So I think that here, if we take out like A, if we try to instantiate A here, it's fine. Yes. When we try to instantiate B here, it's not fine. Cool. And I like, does it matter if I put this, like, if I swap order of something? Does that matter? No, I don't know. Okay. Okay. So we can go into this bug report now. We can say, hit this while trying to use mini audio. And we will maybe link it here. Well, found a stripped down repro, which might be helpful. Okay, so our repro is what? How do you do this? Test.h. We copy paste this stuff. And test.zig. We do this. I guess we don't need this import std anymore. We just need this. Let's just double check that. We don't want to submit an invalid thing. Note. Note. If we try to instantiate CA instead of CB, then it is not a problem. Oopsies. Oh, crap. It is not a problem. Okay. What version are you on? Yeah, we'll get there. We'll get there. Zig 012. But if you're trying to nag me to put in the bug report, then don't worry, we'll get there. Can I preview this? Yeah, I can. Oh, you want me to write zig here? Oh, that's kind of neat. That's kind of neat. I think there are nightly builds of master available. Yeah. I guess I should try it on master, because if I don't try it on master, we can't be sure that it hasn't been fixed already. I'm using a newer version that does not work. I guess not that I don't trust you, but I don't trust you. No offense. You're just a guy on the internet, right? I can't trust other people. Where are the Linux nightlies? Direct download. Downloads page. Linux, is this master? Yes. Linux master x86-64. Zig Linux. Okay. So we can say zig. What was our command? It was zig run, but then we can just kind of slap a little this thing in front of it. Okay. Yep. Cool. So observed on zig version. Oopsies. Wrong window. Zig version 0.12.0 and nightly. This thing. Ethic Bogman. Good eye. Good eye. Run with zig run. And then boom. Okay. I'm not going to go as far as trying to fix it, although it would be kind of fun to. Oh, I guess we should also say that here, we'll do this. If we try to change from CA to CB, then it's no problem. If we replace yeah, the workaround. Yeah. If we replace the function struct a star with any opaque. Oopsies. Zig run. And let's run this. Expected. Oh, oopsies. This is a void. Yep. If we replace struct a star with void star in the function callback, it is not a problem. Okay. Hopefully that's helpful to somebody. Maybe me in the future. Probably not, though, but I like to think that maybe I will be interested enough to try fixing this later. But, okay, so we at least understand the problem enough that we can work around it. I think that that is fine. Absolutely fine. And I'm willing to just plow ahead now. And what we can probably do is we can choose to either mod our function callbacks with void stars, or we can choose to generate the like do a translate C run up front and then replace it in there. And it would be nice to document the changes in some way. So maybe what we're gonna do, we could maybe get fucking crazy. We could generate a patch for the header, then save the patch, and then apply it locally or something before compiling, or we could just like comment in it modded. I don't know if I like either of those solutions. Okay, here's what we'll do. We'll store the original mini audio.h. Yeah. Okay. Here's what we'll do. We'll take mini audio.h. We'll save this, And in our build script, we will manually run zig translate C and then apply a patch manually. And hopefully the zig translate C call is deterministic enough that we can get away with that. And that way we will have like very concrete in the code, what the fuck have we done here? Because otherwise you'll have like this imported header and it's really unclear what is happened to it. Do I like that better? Or could we apply the patch and include the modified source file? Oh, I like that better actually. I like that. So in our wrong fucking window. Where am I? Video editor. So build.zig. Maybe what we do here is, I already forgot. Oh yeah, we want to patch mini audio and then put it in like some cache output directory. And I know that the build system supports like generated files. So we can do something like, okay, we'll put this in mini audio. Shove this in here. Then in the build zig documentation, they have like instructions on how to generate files and use them in future steps. My attention slipped again, but it might be nice to have the diff of the changes in the history. Yeah, I guess you could just add the header and then mod it and then commit the mods, but I'd prefer to have it like there. I don't know, there's something about including a modified dependency. I guess that's the whole point of pulling the dependency in. But it seems likely to me that in the future, not that it fucking matters, right? Because I'm the only person using this and I'll remember, but like the worry is that I will update to a new version of MIDI audio, and the update process needs me to apply those same mods again. So having them like codified is kind of nice because then we can see what the changes that we were doing are, and like we don't have to like go back through history to find them. Generating zig source code is probably the closest. So in the build zig, they add an anonymous import. It's not really the same. We're not trying to add an anonymous import. We're trying to add something to the include path. But I guess add output file arg is probably the thing that I'm looking for. Yeah, so this will give me a location to write the new version of miniaudio.h, and then I can run a system tool to generate it. Cool. Okay, so let's create our mod. And in here, it's just that in our function pointers. Oh, okay, here's what we'll do. We can just put this here for now. And if we run our audio test, he should start failing again. Oh, except our audio test is not using C import. Now he'll fail, and we can just go through and fix these one by one. So this is MA dataproc. Which is this one. MA device notification proc. This one was a bad one as well. Where is the notification proc? Oh, it's saying it over here. Is that it? Yeah, it's just the 3. All right, cool. How did you get into programming video processing? Is this something new? Do you have an existing background with it? I mean, I haven't done this before. I don't even know if I'm really if what we're doing would be considered video processing. We're kind of just like taking frames and shoving them into OpenGL. I mean, I did work with security cameras that had like video processing to some extent in there. And I just kind of like applied for a job and got it. So no existing experience there. But I don't really know how much that's like relevant here. It's hard to know, man. There's like because like what, we're like a sum of our experiences, and so saying like this didn't matter is like so hard to know because you don't know, like you pick stuff up, and so like just doing more things gives you more context to do more things, and so maybe it's relevant, maybe it's not. I don't know, man. But this is new and it's fun, so I don't know. I don't think like, and nothing we've done so far like is requires any like special knowledge. I don't think. It's just kind of like poke and prod until something works. It's kind of the approach that we take to everything around here. Okay, so how do we apply this patch? Also, I think I have like 40,000 Vim windows open, just like kind of like foregrounded on top of each other over and over again. So there we go. I think that's all of them. Okay, so I guess what we can do is we can we want to generate a patch between this and that. So it's patch. How do you generate one? It's been a long time. Oh, it's diff. Diff is the tool to generate. And we diff from res mini audio. Hello? Oh, diff from mini audio to source mini audio. Nope. I guess let's try this. But I don't like this diff look. Maybe it's because I'm too stuck on Git where I get like stuff like this. Maybe, but I guess this is fine. So we'll save this as a mini audio lowercase u. Is that what I want? It's possibly what I want. Yeah, that is what I want. Hell yeah, this is the stuff. This is the stuff. So we'll store this as mini audio. Zig. Where's our Zig 18247 patch? 18247. Yeah. Okay, and then in our build script, we apply the patch. So we'll make a function prepare mini audio. He's probably going to take in the build. And we're going to run some system tool patch. Run system. Here we go. Here we go. Boom. And we'll say tool run add input. Where does the add input file arg? Oh, it's just add file arg. Add file arg. So we are going to work on the mini audio.h. This is not going to be JQ. This is patch. And we're saying patch, I think it's -p1 to apply a patch and strip the A's and B's. What's in our patch here? I guess we don't, if we just delete the prefixes. Right, you can do this. But we could just do patch. So if I say patch mini audio.h zig patch, honk failed. Honk failed. Why? Okay, let's try again. So all this goes away. And we say, diff-u, and we'll now do this. Oopsies. Generate me a patch, please. And then patch. Okay, so that worked. Oh, did it patch it in place? Fuck. It did. Apply patch to stood out. -o-. Okay, so curl and then patch dash o dot dash, cool. And we'll say mini audio 2.h, and then we'll diff mini audio.h and mini audio 2.h. Fuck me, man. Okay, so that did stuff, right? This is this version of mini audio.h sure does have those changes. And so if we say, hey, could we patch so we patch with pnum patch file, original file, patch file. And then that person was saying I can specify an output file instead of patching files in place. Oh, no, I don't. So this patching file read from mini audio.h. And so here if we look for like our stop proc, why is this not fixed? Am I fucking high? Oh, my patch is broken. That would do it. So now are they fixed? Yeah, okay, cool, cool. That does it, okay. So we should be able to remove these and then git add star here just so that we don't get lost. And now we should be able to say patch. We add a file argument of mini audio.h. We add an arg that says output to standard output. And I think add output file arg redirects the standard output to this file, I think. Cool. And then how do we run the tool as part of the build? Install step depends on. So get install step dot depends on tool run step. And so now if we run we need to run this function. So we need to say pair mini audio. And if we do this, we should see our patched mini audio show up in the Zig cache somewhere. Fine, I'll type b.path. If that's what you really want from me, I'll do it. No? Do I have it backwards? It's this way? No. Maybe I'll read the error. I'll actually read it. It's here. It returns me a path of where the thing got output. I don't really give a fuck right now. Expected type build step found build step. So I guess I need to put a little ampersand here. Cannot patch file this thing. No such file or directory. Okay, so what does this guy do? He says add file art. Oh, output is tool run add step. Oops, I have to manually capture stood out. And then they install it. But I kind of want it to end up just in the cache. Can I guess I could just add the argument. Oh, I can just go, I'm an idiot. I'm an idiot. We just, instead of outputting to standard output, we just output to the fucking file that we wanted to output to. I'm gonna, like, why would I do it that way? Okay, so we add arg-o, and then we add the file that we want to output to, then we run it. Okay, so in our cache now, we should be able to find miniaudio.h with our stop proc. No, fuck me, man. Really? Oh, I was so sure. I was so sure that was it. I was so sure. Not adding the patch arg. Oh, yeah, that's a really good point. Yeah, super, super good point. Super good point. So I think it's just like this. I think. Okay, let's try that. So zig cache, some output, mini audio, and we can look for ma stop proc. Boom, baby! Let's fucking go! Okay, so now in our build script, we should return the output here. And we'll call this, what is this, a lazy path? Yeah. Std build lazy path. And then we can prepare mini audio. We'll say mini audio path is equal to this. And then we'll pass these into here. Then in here, our include path needs to include the mini audio path, which is a lazy path. Hell yeah. Okay. And then if we do all of that, oh, we don't need to put a star on him. If we do all of this, then if we just type zig build, I think we get something that works, maybe? Fuck! I need its parent directory, parent directory, parent directory, parent directory. Does he have a... Can I get his parent name out of lazy path, or do it, like, is that just not possible? Relative dir name. Yes. Thank you, God. Wonderful. Maybe. Maybe. Boom, 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 boom. Okay. Sick. Sick. Okay. And then we just have to make sure that we don't have anything else kicking around in here. So let's nuke this guy. We don't need him anymore. This guy now should be using these types of brackets. Actually, for the implementation, we want to use the original. Huh? Maybe it'll be fine. I'm not really sure if, like, the mismatched forward, like, the mismatched function pointers are going to cause problems. They probably will. So let's do this. This will reuse the original mini audio directly, and we'll use the patched one. Res mini audio file not found. Great. Super cool. So I guess, is there a way for us to... Oh, this is going to get so complex. So because of this, like, concern about, like, type mismatch, I want to compile the original for this impl. But this like argument is getting passed into the zig compilation unit of like the whole executable. So it's almost like we want to construct a static library that uses the original with a different include path just to dodge that. That's fucking annoying. But it is what it is. And I don't really know how to make libraries. I've never had to do that. Never had to do that. Static library. So we just call exe.link library on the library that comes out of add static library. Okay. So we say b add static library, and we probably have to pass in nothing. Maybe this is fine. What goes in here? Mini audio path root source file. Is it going to be mad if I try to make a static C library this way? Would it not work to never use the original? Feels like having the wrong prototypes anywhere in the project is risky. Well, that's what I'm trying to avoid. I guess we can find out. We'll find out. It's pretty easy to test that, huh? Let's test it and then come back to this. So if we go to the Zig cache output and look for mini audio .h, where is he gone? Here. Zig stop proc. Okay, this is using that one. And if we say gcc define mini audio implementation on, and then run mini audio.h. How do I export a static library again? What is the gcc? Oh, -o test auto. Am I high? GC. Oh, just -c. Right. Oh, it does look okay. Unless I spelled mini audio implementation wrong. Okay, maybe I was just all up in arms about nothing. Yeah, I was concerned, but I guess it's fine. Surprising. Okay, because I'm deleting the cache because I was like fucking with it manually. And I guess you're right. We don't have to worry about this. All right. Cool. So that's an hour 25, and we've done literally nothing. Super sick. But at least now we can, well, probably we're going to end up actually writing like 2 more lines of code and hitting the same problem again. That's actually extremely likely. But at least we know what the problem is. Okay, so let's go back to trying to get a little farther down this road. So it was like this. This comes from CMA format 32, and we have our own data callback, but in this language, we are supposed to be doing this. We don't have any user data right now, and let's try uncommenting this function, and hopefully it's all just okay. No field named C in enum. Oh. Is it capital C here when I do my calling convention? Might be. Expected type this fucker. Found type this fucker. So found. I need to change this to any opaque now. Any opaque. Spirit on. Thanks for the raid. Appreciate it. What's up, you guys? For the new people, we were trying to work on today getting audio callbacks working. Okay, context. instead of me just telling you the like narrow version, let's look at the big version. Let's see if this runs right now. Zig, build, and run. Okay, so we have this like video player. Right now, he is taking frames from FFmpeg and he's spitting them into an OpenGL texture that we're displaying in a GLFW window. The reason we're doing this is because we want to make a video editor that makes it easy to like clip and ship stuff. So the idea is I'm going to take my big ass VOD, I'm going to run it through some sort of like subtitle generator, and I want to be able to basically select chunks of text and say I want this in the video or I don't want this in the video. Haven't really decided like which way we're going to do it yet. So that we're working towards that. Right now we're working on the video player at all. We need to have a functional video player or else we're not going to be able to interact with this thing. And so today we were going to work on audio. We pulled in this audio dependency and we found a bug in Zig and we added on to this existing bug report with like a little bit of a stripped down test case for how to reproduce it. Then we now understand the problem well enough that we can work around it. This problem is like related to function pointers to a struct, two structs using the same function pointer who is referencing one of those two structs. Weird edge case, doesn't matter. So we kind of got that out of the way. We hooked up to our build system. Like we pulled in the dependency, patched the dependency as part of our build, and now we're back to actually trying to use the dependency again. So we're right now just trying to set up this like audio callback. We're expecting to run into more problems, but for now we're just trying to get compiling and run their example. Okay. So I think we build. Let's just make sure that we're building what I think we're building. So if I just introduce a compilation error, he gets angry, sick, everyone's happy. And let's keep going. So we have some device who was... Oh, he is a var device who was a CMA device undefined. And then we call CMA device init with null and our device, and we check if that's not equal to CMA success. And then instead of returning -1, we will return some error. So we'll say failed to init device. And then we'll return error device init. I guess it doesn't really matter. This is kind of scratch code, so we're actually not going to end up using this directly. We start the device, and then we uninit the device, and that doesn't compile anymore because this guy can return an error probably. I wish I could jump to definition on there, so we'll just restart, and hopefully that kicks the language server into a state where it works. But no such luck. But we can just look at the implementation here. MA device start. So what's going on here? MA result. So presumably, MA result is something that can be true or false. Enum, MA, enum, type def, MA result. Here we go. Yeah, okay. So we'll just say if this is not equal, what is going on? Oh, there's a comment in there. Stupid line wrapping was tricking my dumb brain. If this is not equal to MA success, we'll say failed to init start playback. And Zig build. We build, and then I'm going to mute the output from OBS before running this because I don't know if it's gonna like fuck up my ears. So we'll say Zig build and run our audio test. And we're mostly chilling. Looks like he's mad about some sort of mem copy here. No address available. So I guess there's a chance that we kind of fucked up with our void star casting. It'd be interesting to look at. This is at 41699. No, he seems fine. It seems fine. Probably. So this is coming from... Well, did we fuck something else up here? What is like MA device init? So we have some device, and when we try to initialize him, we try to device start. And we are crashing in device init. LOL playing around with the Zig bug you found. I got the compiler to segfault. Oh, sick. Congrats. That's kind of fun. Let's try GDBing this thing. Okay. Oh. Is it because, like, I'm immediately quitting? Am I supposed to be, like, doing, like, while true? Run. Oh, no. Okay, here we go. Here's the segfault. Okay, so at frame 4, we're calling MA device init with config. There is a lot of invalid memory in the config. I didn't zero it out. Did they zero it out in their example? Oh, they called MA device init. We just didn't do that. So that's probably the issue. CMA device type playback. That would do it. That would do it. And hopefully this still compiles. But it might not. But it might. We're chilling. Zig build run. Oopsie. Zig build and run the audio test. Okay, so nothing's happening. Is there a way for me to see if there's, like, my system thinks that something's happening? Does this not show processes here? I know I have this, like, widget in the bottom right, but it's, like, covered by a bunch of shit. I do, like, pavu control. I just want something that shows me audio streams that are currently active. Give him a sec, he's gotta think. Pavu control. And do we have, like, playback? Oh, this is... Oh no, this is stream stimulator. That's this guy. So it doesn't really feel like it did anything, huh? If I run this guy and he just, like, starts and stops, that's fine. How do I think there's, he might be using ALSA. ALSA list streams. Or, like, I don't even know what sound server I'm using. I'm using Pipewire. How do I check? Pipewire, is Pipewire or Pulse or ALSA running? How do I know what I'm, like, I don't want to know which, I don't want to know, like, how to pick. I want to know just what the fuck is running right now on my system. Maybe we can do, like, PS, everything, grep, pulse, grep. Okay, this is damning. So let's see. How do we test this? Okay, let's go back to this never close the stream thing. And so now, theoretically, an audio stream should be open. What happens if I try to add an audio stream in OBS? Audio capture device, audio output capture, Pipewire. Oh, this is by device, fuck. Fuck me. So I can't just capture, like, is there no, like, application audio capture in here? It doesn't look like there is. Oh, application audio capture. Here we go. Application. Is anything in here look like my thing? Audio test, right here. Oh, but it might just be listing all applications, which also isn't very useful. We don't really know. Here, there's PW top. We're on Pipewire. Oh, yeah, nice. Okay. We do see a mini audio thing in there that goes away. Okay, that's a really... This guy's in there for sure. Sick. Okay. So we have, like, an audio stream. And I guess all we want to do is we want to feed some data into it. So, in playback mode, copy data to P output. So never process more than frame count frames. And what are my things? I have a device that I pull in, output, input, and frame count. So I don't know if they're expecting exactly frame count frames. Never process more than frame count frames. Seems like they're kind of saying I could process less, but how would they know how many I processed? Surely I have to fill up the entire output buffer, right? It's also kind of crazy that they just give me output and input, and they're just like, I don't know, you figure out which mode you're in. That seems crazy to me. It seems like you should have one callback for output and one for input, but what do I know? What do I know? Okay. So, is there an example of like... Yeah, we'll fucking figure it out. So we know that our sample rate is supposed to be 48,000. So if we wanted to play a... First of all, I don't know what a reasonable sine wave frequency is. Can we just like... Sine wave sound. 1 kilohertz sine wave. That's... pretty high. Can I go... like less than that, like 440 hertz. Shut up. Oh my god. Skip. Yeah, okay, 440 hertz. That sounds fine. So that's like about like this over 100. So this is something like we're going to have to put in samples of some format. I don't even know the format. MA format F32. Let's do one channel for now, just to simplify things. And so if we are at 48,000 samples per second, and we're trying to inject a 440, we'll say 480 hertz. So this is SPS, S/S is not helpful here. So we'll call this I don't know, like item per second or something. It doesn't matter. 480 is seconds per item. And this is items per second as well. So if we were to take in like our step, at each step we're gonna put in frame count things. So maybe we'll just stick in a globe right now, like samples provided. And let's say that they give us like, they say, hey, could you give us 1,000 samples? We should give them some time step of samples. So it's like for 0 to frame count, we need to do something, right? I don't know what yet. We have to do something. We have some output, which we're gonna cast our output. Is question mark star, somebody said question mark star any opaque? Is that wrong here? Am I just supposed to write any opaque and not question mark star any opaque? No, I think question mark star any opaque is saying like I have a pointer to something and I don't know what it is. I'm pretty sure. And so we're gonna do something with this index. So we have some function that's like sine something. Okay, let's ignore the sampling stuff. Say we want to generate a 440 hertz wave. Sine normally goes from 0 to 2 pi. So if we want, this is 1 period. So if we wanted 1 sample per second, if we wanted 1 full movement of the sine wave per second, we would do sine time step times 2 pi. Because then when the input is, if time step equals 1, then we get sine 2 pi, which gives us 0. Yeah. Okay. And then if our sample rate is 48,000, then we just divide this by the sample rate and then multiply it by the desired frequency. Oh, I also forgot to unmute the desktop audio when I was playing sine waves for you guys earlier, but this is what I was trying to get out. Okay. I think this is right. I'm not really sure, but we'll find out. So we'll say time or samples provided plus equals I. And then we will just say that our output as floats is going to be some sort of like slice of F32s. Maybe. And that's going to come from, I guess we'll start by saying that it is a array pointer of F32s. And this is going to be the pointer cast of output. Then we can say output F at I. I don't know if this is valid Zig syntax, but we'll find out. Is at sign samples provided times stood math.py times 2 divided by the sample rate times desired frequency. And maybe it makes, oh, it's fine. It's fine. And here we will do as F32 float from in of this thing. Yeah, sure. I don't really know if that's right, but pointer cast increases pointer alignment, so we have to say align cast here. And I'm going to mute the audio again before running this so that you guys don't die. I'm hearing nothing. Nothing, which is not good. Not good. It's also kind of surprising. I wonder if this, is this code running? I guess we can find out by running GDB. Yeah, it is running. Okay, and we have 480 frames here. Okay, and there's lots of things that could be going wrong here, to be honest. Lots of things, because we're kind of just guessing what's supposed to happen. It would be interesting to maybe stood debug print the array that we are returning, which is output from as floats from 0 to frame count. Let's just see if that looks like anything sane. Zig build and run the audio test. Core dumped. Core dumped. Okay. Okay. Let's maybe, before we do this, print the frame count is going to be a frame a number. Let's just see if this is something interesting. Hello, computer? Jeez. He's mad at me. I'm indexing a finite buffer with infinitely growing samples provided? I don't think so. I don't think so. Samples provided is only an input to our sine function. It's only input to our sine function, so I think it should be fine. I guess we don't really know MA format F32. 32-bit floating point in the range of -1 to 1. So sign is giving us, should be giving us -1 to 1. Which I do believe is happening. Okay, so there he's not crashing, and he is giving us something. It's very, very likely that the math is wrong here. This stuff looks like it's moving pretty quick. So... Oh, but I guess it should move pretty quick. Let me think. So we could do... Let's double check this output math again. So we have some number of samples provided. Say that this number is 48,000. What do we get if we plug that in here? 48,000 times std math pi over 2 times std math pi times 2 by 48,000 times 440. That gives us 48,000 cancels out with 48,000. And then we get 2 pi times 440, which is the number of iterations that we wanted in 1 second. So that all feels right to me. That all feels right. Is there like something about like volume of the stream that's coming out maybe? Let's get rid of these prints because I'm sure that's clogging up our callback. In capture and in full duplex mode, these will be valid and you can move data from P input to output. Never process more than frame count frames. Samples provided plus equals I should be plus equals 1. That's a really good point. That's a very, very good point. I guess the fact that occasionally we segvault here is a really good indication that we're doing something fucking stupid. Right? Really good chance. So maybe let's look at the miniaudio.h again and look at well, maybe they have examples on their website actually. Maybe starting there makes simple capture, simple playback. Oh, wait, this is exactly what we want. Simple playback's fine. So they make MA waveform read PCM frames. MA waveform config. Oh, they're using the high level version, I think. Oh, maybe not. So here they're saying start this device, and we got this device by doing this. Then they wait forever while the audio thread calls into their data callback. Okay. And then the only thing that they're doing that we aren't is they're doing like MA waveform read PCM frames, but I feel like we should just be able to shove PCA frames in directly. What is that? MA waveform read PCM frames. Yeah, this is generation of stuff, but I don't want to use their generation. I want to feed in my stuff directly. But I guess we could start by trying that so that we have like a sane sample. Zig's A.B syntax is not inclusive, is it? No, I don't think so. Oh, so you think this should be frame count plus 1? I think that even if we were off by 1 here, the difference, like we should still be hearing something that's like not nothing. If that makes sense. Also, this seg fault is like a really good indication that we're doing something fucking wrong. So what I wanted to know was what the frame count is. In the above example, data callback is where audio data is written and read from the device. The idea is that in playback mode, you cause sound to be emitted from the speakers by writing audio data to the output buffer. In capture mode, you read the blah, blah, blah. I don't care about capture mode right now. The frame count parameter tells you how many frames can be written to the output buffer and read from the input buffer. A frame is one sample for each channel. One sample for each channel. For example, in a stereo stream, one frame is 2 samples. Okay. The channel count is defined by the device config. Okay. Multi-channel audio. So I guess there's a few things that could be going wrong here. Maybe the config we set isn't necessarily the config we got. And what was the other thing that I thought it might be? I already forgot. Oh yeah, I thought that maybe it's like stereo. It's coming in stereo and we don't expect it to be. You're saying like maybe -1. I don't see why -1 would ever be what we need here. But you check. So before we were segfaulting, when we tried to print out the output, so maybe it's just like we were backing up the audio for it, the audio callback thread too much that was causing problems, because writing this isn't causing any problems. What happens if I go back to 2 channels here? Ooh, okay, that's interesting. So that's something. Sorry, your guys' ears are probably like fucking freaking out. Okay, so it's possible that one channel did not give us something sane. So if we do 2 channels, this should be easy where we just go for 0 to 2. We do this. I'm pretty sure this should be like this. Still not good. Still not good. Right, so I plus J. Still not pleasant on my ears at all. At all. That's not like too loud right now after I turned it down, right? That's like fine for you guys. I'm assuming it is, but I don't want to like ruin y'all's ears. I guess people aren't screaming ow in chat, which really indicates that it's okay. Okay, so for each frame in frame count, we are going to I equals 0 and I equals 1, assigning... Oh, this should be I times 2. There it is. Okay. All right. Not bad at all. Okay, so I think we get it now. So I guess the question is, why when I set this to 1, was this not working? So here, let's split out a const num channels is equal to 2. What type of this is this? I guess we'll find out real quick. If I try to write usize here, I guess I'll just leave it as a comp time, and then we can set this everywhere. Num channels is here and here and here. So I don't understand why, if I set this to 1, we just get nothing back. It's possible that we just, that the initialization gave us something different. Can we look at, maybe we can look at our device in here. So let's look at, const device, we'll call this device v for void. We'll call this device as a, CMA device pointer. And so we'll say, this is please, pointer cast, align cast this device v that came in. And then let's look at what's in there. So MA device struct ma device. Here we go. So we can look at his sample rate. Does he not have num channels in here? Oh, here, struct playback. So we can look at the device playback channels. I guess maybe it makes more sense to just breakpoint here and look at it. But maybe we need to print something from it so that the debugger has something to look at. So here we'll print the number of channels, but then we'll still have the debugger. Okay, so here he does see one channel. And can we GDB this thing? I guess we need to yank here. GDB, break on this, run. And what's in here? P device. Jesus. Playback. P device. Is it P device arrow playback? Does that work here? It does. It does. So we do have a 48K sample rate and single channel. So I don't understand why if we weren't in stereo mode it doesn't work. Maybe it's picking a different output device. If like I don't know what this like device finder is doing, to be honest. I have a FFmpeg mini audio example I made a while ago if you want. That's cheating. No cheating. However, I appreciate it. But I think it's more fun to struggle through it this way. So if I have like multiple audio output devices, right? Like I have an HDMI out, this like sync and like a line out. How do I know which one it chooses? That's the only reason I can think of that this wouldn't be working when I go to one channel. Because it seems it's like we have, as far as I can tell, a valid device. I wonder if I can like print the name of the device. MA device. MA device. Struct MA device. What's in this guy? Device type. Are you sure the NAO pick is the same as the sign outputs for both single and double channel? There is a type enum in the playback, I think, to see if that changes. Are we sure is the same type? So you think like in single channel he might have not chosen floats? That seems possible. We have in here the sample format somewhere. Internal format 5. So can we look at what MA format F32? Where is this defined? 5. So I don't really see. I don't see that it would be a problem here because if our structure here is telling us that it has format 5, I don't see why it would be lying. Null playback device. That'll fucking do it. That will fucking do it. So I bet you if we turn this back to 2, and then we run this again and run it with GDB. Fuck, I need to yank the line again. It was here. Oopsies, what am I doing? GDB, break here, run. And here we should be able to say print device playback. And here it's default playback device instead of null. So whatever the audio library is doing when we ask it to initialize device, he's like looking for the best device, and then the best device for that configuration was null. Which is interesting. It kind of seems like we should like what is like the sane behavior here? The sane behavior is that the user says which audio device they want. Or maybe not the user, right? I guess there's we should ask the system what the default is, and then we should force it to fucking use that. And if it can't use that, then we should fail and ask the user if they want to use a different one. That seems like the most sane thing. Which makes me think that in the config, there should be some way to specify which device we want. Why is it to succeed if the device is null? Yeah, I agree. I agree. Okay. So, device type. Like, what are any of these things like the device that we want? MA device ID. This seems like what we want. So, MA device ID has some union. It's a union of which backend to use, where if it uses ALSA, it will give a name, or if it uses Pulse, it'll use a name. So that means that here, how does it know which version of the union to be using? Right, so if this thing's a union, how do they extract the right piece out of it? You know? Or it's a union MA. Union MA. I lost it. Oh, this is, oh, sorry. MA device info is not the union. MA device ID is the union. And so somehow they must go from do they not have like some sort of like tag? I guess we can look for ID dot ALSA and figure out how they get there. I see. So they know which backend is being used, and so that they know which one of these guys to look at depending on the backend that's in use. So here, probably somewhere we can iterate these like device infos. Simple enumeration. Yeah. So we can say, hey, could you list the devices? And then we will pick one. And then we will force you to use that in when we configure the device. That makes sense so far. MA context get devices as well. See also MA context get devices. It is not safe to assume that the first thing is the default device. Sure, but how do I find the default device? If you have multiple physical devices and you want to use a specific one, you have to specify the device ID configuration. Yeah, okay. To retrieve the device ID, oh, cool. So just like maybe like 6 lines down from where we were looking before, it's going over exactly what I'm confused about. So they get the devices, and then they loop over the device, they print them out, and chosen player. But how do they know which one's default? If you have multiple physical devices, you want to use a specific one. Like the system has one selected, right? Like if I go into my audio devices, how come it was there a second ago, not now? Okay, like this is selected. So what does this do? This must go into Pipewire and flag it in some way. And it also, I think that it's also Is it also mixer? Oh wait, we're probably using, it's using the pipewire, the pulse audio backend. Yeah, it has pulse audio backend. So he must ask pulse audio. He must ask pulse audio somewhere what the default is. So how do we go from device enumeration to enumerate devices pulse? Okay. Get default device index pulse. Okay. This is good. And then what does he do with this? He puts this into default device index playback, which is must be used somewhere. Device info is default. So I just didn't read this whole struct. So we iterate these guys, we check which one is the default, and we just use that one, and we force it. And if that doesn't work, then hopefully this will fail. Okay. Okay, so we can go back to their example here where they iterate the devices. So we don't have a context yet, I don't think. No, we don't. So we must just have to make one, I guess, before we do anything else. Okay, undefined, not null. Then we try to initialize it. So we will copy paste this and we will call this context with null, 0, null, and context. I don't know what those do, but that's fine. And we will say failed to init context. We will say, hey, we have some infos, which is I guess is going to be a list of infos that we could get. No, he's going to allocate this for us. He's going to allocate this for us. It looks like. Which kind of indicates that we're going to have to free those things. But he doesn't say that. So probably it's going to be part of the context. And we're going to have to, when we free the context, all of that stuff gets freed probably. That's just my guess based off the docs, but I mean, I've made a lot of bad guesses today, so. You know, who fucking knows? So here we will call this a C pointer to a CMA device info is equal to undefined, and we'll say num playback infos is going to be a CMA unit32. Also undefined. And then we will call this function with the context, the playback info is playback count. These guys are going to be null and null. The null device probably exists to have a fallback on a system without audio hardware. It just seems crazy to me that your default would be to allow using the null device, though. Like, that's just, like, really unexpected behavior to me. Like, I would think that you have to specifically opt in, but sure, I get it. Like, it makes sense to have it as an option so that, like, you can, like, fulfill your interfaces and stuff. And just, I'm surprised that it works by default. I guess probably there's a way to turn it off, huh? I think I saw that they have, like, backends that you can, yeah. This probably would have helped us, but it's too late now. Well, it's not too late, but I don't care. I guess. I want to keep doing this, what we're doing, because I think this is more correct anyways. So here we'll say failed to get devices. And this is playback infos. And this is num playback infos like this. And this is CMA success. And now we should be able to say for playback infos from 0 to num playback infos, we have an info. And then we're going to say var selected device is equal to 0, which is probably going to be a C, MA, uint32. And then we're just going to say if info.isDefault selected device is equal to, I guess we need to take in an index here, which kind of makes this a usize. And then down here, wherever we set the device that we want, I think we had to set that in the config, right? Yeah. Config playback p device ID is equal to our playback infos at selected device. Boom. So hopefully this all just still works. Let's make sure our num channels is 2. It is. So zig, build, and run. We're not good because it has no member on init. Right, of course. This should be an underscore. And this should be... no, this should be context here. I'm just high. High as shit, I guess. Found uint for isDefault. So we'll just do a little not equal 0 there. P device ID, no field name P device ID. Is it, oh, capital D. For identifier. Of course. And then this device ID is, I need to write .id here. So they want that. Okay, so that's still working with 2 channels. And now if I do 1 channel, what I hope is that this will fail. No, it just still fuck off. So here, do I have to assert now that the fucking device that we got is the one that we asked for? No failed name P device ID on playback of the device. MA device struct MA device. All right. So here we have our playback section here, and does he not have the device ID in here? P ID, of course. Of course. Why would it be what it was in the other one? Okay, so this now asserts because those things are not the same, and if we set this to 2, it probably will assert that they're true. No. Oh, interesting. What is the difference? MA device ID. P device ID. Set to null if using default ID. Otherwise, set to the address of ID. Maybe this is what I want. ID and this. Oops, this needs to be like this. We dereference on the other side in this language. Comparator not allowed for MA device ID. Great. Because this is some complex type. Of course. Of course. Try to find MA debug output. Yeah, I guess that's not a bad idea. So I guess this would be in the impl here. Define MA debug output, probably. Oops, I can't do that comparison still. Assert. Where is my assertion? Get this shit out of here. Okay, so that's 2 channel. 1 channel. Okay. So here he said, okay, still ended up on the null playback device. No, that's not too helpful. Not super helpful. Oi, 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 oi. Struct MA device. It's crazy to me that I guess we should just look at what the device ID is. I guess we should just fucking actually debug. Hit the debugger. And probably in a new window, actually. Nick Shell. Oops. Let's get GDB in here. Give him a sec. He's got to think. He's got some stuff to get from the internet, but it's not actually from the internet. It's actually from the hard drive. I don't know what he's doing in all this time, but it's okay. Okay. I don't care about these epoll events. Okay. And if I say, hey, can we look at the device, please? This is a lot to take in. Device playback ID. Oh, we know that this is... Sorry, let's go back to the one where it's working. I want to look at the working example, not the broken example. Zig build. Okay, GDB. Break here. Run. I have to... Oopsies. Okay. Epoll. P device. Fuck. P device playback.id. Might be null here, to be honest. PID, sorry, that's what I want. Which doesn't really seem to have anything that interesting in it. Even though it was working. Right? This is the functional case. What did our config say? P config playback P device ID. Okay. So this is also kind of just giving us zeros here, which doesn't quite feel right to me. What else do we have in here? We could print the name of this guy. So we could look at... We could look at the playback infos at selected device. And hopefully we see is default 1, so that's good. And it's got the name default playback device. Great. And if we look at the device that we have, can we get his name? Is that possible? Okay, so it does say it here, wherever the fuck this is. Which is in custom somewhere. Geez, why is this formatted this way? What an awful fucking way to print stuff. So this is next to ID, which is in playback. Yeah. So device, playback. Name? Okay, yeah, here we go. We have name and ID. So in this scenario, set print pretty Is it not? I thought I had that on by default. Oh, that's so much better. Thank you. I thought that I had that somewhere in a config, and then I thought that, yeah, I've looked at this before. I just lost it. Thank you, thank you, thank you, thank you. Okay, so in this scenario, we got the device that is default. Oh, can we just check if device playback does it have is default? No, it doesn't. P device, does he have like is default anywhere? No. So I'm a little confused about how the device ID device playback ID, this is just like hard 0, right? This is showing us a union where everything in it is 0. And if we look at the config playback P device ID, and we dereference this, that's also like hard 0. So that's fine by me, right? I don't have a problem with that. But if we go to num channels 1, and we do the same thing, give it a sec, set print pretty, and we say print config playback P device ID, and we dereference this. It's like, again, hard 0, right? Like, super fucking hard 0. And if we look at P device playback ID, it's like hard 0. So it's like, what the fuck is going on here? How come we can have the same thing in these two situations and have them just be like completely fucking different? It's possible that the pulse audio default just is hard coded to 0, and then it switches behavior based off of what's available. That seems possible. So it's right, because we saw the name is default audio device in the config, right? If we look at what was it called? It was P playback infos selected device. His name is just straight up default playback device. So it might be that it's doing something stupid. Like Pulse Audio might be doing something like a little bit silly under the hood. And wait, hold on. P device. No, he does still say null playback device, which is a different thing. I wonder if like our config maybe has to say like don't fucking fallback. Here they're not really saying to do that. MA device config. Is that what the thing we were setting? Yeah, it is. Is there like a fallback flag in here? I'm kind of hung up on the fact that the device ID is the same here. But like this device ID is like hard useless, it feels like. Where was it? Where was it? Capture playback, right? Like the fact that this ID is just pulse 0000, like what the fuck? I wonder what happens if you define MA no null. That's a good question. Do I have to define this on both cases or just on the impulse side? I think probably we'll try here. Define MA no null. I am curious what happens there. He's working hard. Oh, failed to init device. Okay. And then here the debug is saying null backend is disabled. Oh. He's probably failing to initialize pulse audio and then falling back to null. So the behavior of us saying, hey, we want this device in this configuration, and pulse audio goes, no. And then we give up? So where does this initialization happen? I'm a little flaky right now. So if I go here and I say std debug print initializing device. Fuck it, we'll have the fucking caps in there because it'll reflect how angry we are right now. Where does that happen? Initializing device here. So back here, it actually failed to initialize pulse audio, which is a little surprising to me. How did we enumerate the devices if he couldn't load pulse audio? Oh, because we're using jack, probably. Okay. Because I know that Pipewire exposes both a pulse audio and jack backend, so that must be what's happening. But then it doesn't really say. Let's see what happens what it does when we say num channels 2. Let's see what it does different. Yeah, okay, so he initializes the jack playback device, and it just must be that when we set it to 1, it fails. And going back to the null device as a fallback, it's just I don't like that decision. So I think compiling with ma no null makes sense for us, right? Because we want to fail in that case. So I think that makes sense. Okay, we're at 2.5 hours, so I think it is time to call it. Thanks for watching, guys. We didn't really do much of what we tried to accomplish today. We did a lot of, probably the part where we were, actually attempting to play a sine wave was, arguably not that much, right? Maybe, 15 minutes of, actually trying to set this up. But we had a lot of fun debugging the zig-c interop, where we were ending up with some invalid zig triggered by mini audio. We found a good workaround for that. We committed a patch to our repo that will auto patch mini audio on the fly during build, which is pretty cool, pretty fun. And then we updated the bug report there somewhere. Do you have Pipewire also installed? Probably not. The fact that it's ending up at jack kind of indicates that it's it failed to load pulse, it failed to load ALSA, so it just must be something. It's some Nix bullshit. Yeah, and then we got our sine wave going, and then started looking into why mini audio was not behaving the way we expected, and it's just related to him trying to output to if we give it a config that we don't like, that it doesn't like, then he just gives the fuck up. And so I guess there's something about we should be walking the configs in a certain way, and I guess it also means that we should be handling when we play our audio back something related to if the audio is at some sample rate that we don't support, we need to try to find the best sample rate that's the closest to what we support, to what the file is, and then do some sort of remapping probably, right? If we have mono input and stereo output only, then we're gonna have to duplicate the signal, stuff like that. So got a bit of a feel there. We'll probably just run back at it tomorrow, slam our heads into the wall some more, and yeah, thanks for watching, guys. If you like what you saw, there's a YouTube link and a GitHub link in the Twitch description. YouTube has playlists for all the projects we've been working on. So I always forget what's in there. So if we just look at them, right? We have video editor, QR code decoder, zlib, git GUI, TV tracker, neural network, operating system, stuff like that. File systems, terminal emulator. So we trend towards low-level stuff, but generally it's just kind of whatever the fuck I want to do, and that just happens to be something that some people want to watch as well. So that's all there if you want to check it out. If you're watching on YouTube, there should be a Twitch link in the YouTube description. And I think that's all we got to plug. So, bye, YouTube viewers. Twitch viewers, let's figure out who we want to raid.